Today's Mathcast is intended for grade 4. The learning objective is to multiply 2-digit by 2-digit numbers using 4 partial products created by Mackenzie Whitmore. Here is some vocabulary. Area model, a diagram used for multiplication and division in which the factors of the quotient defines the length and width of the model. Then you add to get the area of the whole, which is the product of the quotient. And then partial products, the product of one term of a multiplicative and one term of its multiplier. So, for a warm-up, I will teach you how to draw a unit fraction. So, first, we have a quadrilateral. This means 4 right angles and 4 equal sides. Now, if you partition it into 4 equal sections, and then you shade in one part of the quadrilateral, what does that equal? It equals 1/4 of a fraction. Now, if you were to do this again with the same quadrilateral, but you partition it into 5 equal sections, and then you shade in 2 parts of the quadrilateral, what does that give you? That gives you 2/5 of the fraction. So let's start with example 1. Mr. Goggins set up 30 rows of chairs in the gymnasium. If each row had 35 chairs, how many chairs did Mr. Goggins set up? We're going to draw an area model to represent and help solve this problem. So, as you can see, I set up this area model, and you split it down in half. So since there was 35 chairs and 30 rows of chairs, you write 30 on this side, and then you write 35. Now, to get the answer, you take 30 times 30. This is 3 tens times 3 tens, and that equals 9 hundredths. Then you go over to this section, and you do 30 times 5, which is 3 tens times 5 ones, equaling 15 ones. And then you come over here, and this is how you set up the problem. 35 times 30 equals 150, and then 900, add those up, and then you get 1,050. So the answer is Mr. Goggins set up 1,050 chairs. Sorry for the messy cross-out, but example 2, we will be doing the same problem but with different numbers. So Mr. Goggins set up additional 4 rows of chairs with 35 chairs in each row. Let's change our area model to represent the additional rows. So once again, we have this giant area model. You split it down like this now, because you have 4 rows with 35 chairs. So you take 30 and 5, and then 30 and 4. You put the lesser numbers at the top because they're smaller than the bigger numbers. So 4 times 30, 4 ones times 3 tens. And then you do 30 times 30, 3 tens times 3 tens. You come over to this side, 4 times 5 is 4 ones times 5 ones. And then to finish it off, 30 times 5, 3 tens and 5 ones. And now we have to finish the problem. So this time you take 34 times 35, and then we use the distributive property. So we write in parentheses 4 times 5, 4 times 30, plus 3 times 5, plus 30 times 30. And then you continue it even more to 20 plus 120 plus 150 plus 900. You add all those together, and then you get 1,190 chairs. Right here is an example from the module on how you would set up the problem. For example 3, this will be a wrap-up. You got this. We are going to solve 23 by 31 using an area model to model the product. So basically, we will use an area model and partial products to solve this problem. So once again, we have our area model, splitting it in both ways. So you have 23 and 31. So you would take 3 times 30, and that's 9 tenths. 20 times 30, 6 hundredths. 3 times 1 is 3 ones, and 20 times 1 is 2 tenths. So you would come over here, and you would do 31 times 23, but you would take it one at a time. So 3 times 1 is 3. And then you would continue 90, 20, 600, getting 713. And down here is another way to do it. 23 times 31 equals, in parentheses, 3 times 1 plus 3 times 30 plus 20 times 1 plus 20 times 30, getting 713. So, as a wrap-up, you went over how to draw a unit fraction. You used an area model and multiplied 2-digit by 2-digit. You used the distributive property to represent and solve 2-digit by 2-digit multiplication. And you used both an area model and partial products to solve for the answer. Thank you for watching my Mathcast.